identifying the type of a percent problem, and then also being able to solve all those types of different percent problems. So we have learned a few different types of percent problems. So we're going to call them these 4 different types. So when we're talking about the type of percent problems, these are the ways that we're going to represent them. So we have percent of a number. We have simple interest ones. We have calculating the percent increase decrease, and then also using the percent increase decrease. So this video is really going to be going through how we do all of these. So one of the harder parts is just figuring out when I get a problem, like what kind of problem is it? What tools do I need to use in order to solve this problem? So I kind of set up our problems like this. So this is the process that I would recommend going through when you're trying to solve these problems. So the problem for this one is there were 324 people signed up for gym memberships in 2015. In 2016, the number of gym memberships increased to 549. What was the percent increase or the percent increase? So on this one, we are told really what we're supposed to be figuring out. So the type of the problem is really listed right here. So the type of problem that we're doing is a percent increase. So we're going to be using the percent increase steps when we were calculating that percent change. So percent increase or percent change. And then when we have a word problem, it's always good to just ask yourself, what is the problem asking you to find? So we're trying to figure out what the percent increase, so we're going to have a percent for an answer, percent increase of memberships. So then we're going to solve it. We're going to use the process that we did for percent change. We're going to take the new minus the original, and then we're going to divide that by the original. So the new amount is 549, and the old amount, or the original, is 324. And we're going to divide that by the original, which is 324. So the subtraction, when I do that, I get 225 divided by 324. So when I put that into my calculator, I end up with 0.69. And then you're just going to change that decimal to a percent, which would be 69%. So this would be saying that it's a 69% increase. And then if you think about your answer, it's always good when you're doing a word problem to say, does that answer make sense for what I'm dealing with? So if it went from 324 to 549, you can kind of think it didn't almost double. So it went up by over half of what it was. So kind of just thinking, does that percent actually match what numbers I was dealing with? The next one here says you invested $957 and received $1,416.36 after 8 years. What was the interest rate? So when we're talking about interest, so when we hear words about interest rate, we should probably think that it's going to be related to our simple interest type problem. And the problem is asking me to find right here, it's asking me to find the interest rate. So when I'm solving, I'm going to be using my simple interest formula. So I equals PRT. And I'm going to fill in what I know. So the interest, what I'm actually going to have to do is I'm going to have to take these two amounts, because I can't say that the $1,416.36, that's not the amount of interest. That's how much my account would be after 8 years. So I would subtract those two numbers, and that's going to give me the interest, which is $459.36. The principal is what it started at, so 957. The rate is what I am looking for. So the rate is the amount that the interest rate that I'm trying to figure out. And then the T is the number of years. So we have 8. And then I'm just going to solve for the R. So I'm going to first start with doing 957 times the 8 here. And when I multiply that, I am going to get 7,656. And if I'm solving for R, I'm going to have to get it by itself, I have to divide both sides by the 7,656. So what that gives me on my calculator is this. So that decimal 0.06, I'm going to change that to a percent, and that's 6%. And that answer would make sense because interest rate for accounts is usually, it's a pretty small amount. 6% increase or a 6% interest rate seems reasonable for the situation. Next one, 38 is 47.5% of what number? So this is the type of problem, if I were going to name it with those ones that I said at the beginning of the video, I would just call this a percent of a number type problem. I'm missing like a percent of a number. So what is the problem asking me to find? I'm looking for the whole part of the number, because I know 38 is the part and 47.5 is the percent. So then I'm going to use this form where we fill in. Remember, this is our part up here, this is our whole, and this is our percent on the right side. So I know my percent, so I'm going to put that in there. And the part that gives us a clue word that 38 is our part. And I am missing the whole. So for this, I would probably go and I'd do cross multiplication. So I'd multiply 38 times 100, which is 3,800. And then I'd divide it by 47.5. So I'd get that X is 80. And if I think about, does that make sense? Well, 38 out of 80, that's a little bit less than half, because 40 out of 80 is half, which makes sense for what this percent is, because 47.5 is a little bit less than half. So it does make sense for what numbers I'm dealing with. Next one, a sweatshirt originally cost $35.99. It is currently on sale for 30% off. What is the sale price of this sweatshirt? So this one would be using the percent change. Now, the reason why that I know it's using the percent change, see how it gives me a percent? So a sale means that it's going to be changing by 30% off, and it's going to be going down. It's a 30% decrease. So I'm going to be using that percent to figure out the new amount, that new decreased price. So I'm looking for the sale price of the sweatshirt. That's what I'm trying to figure out. So I know it has to be less than $35.99, because if something's on sale, it has to be less than that. So to solve it, I'm going to take what the sweatshirt cost at the beginning and multiply it times the 30%. But I need to change 30% as a decimal. So that would be 0.30. So when I multiply that, I would have to round it, but when I multiply it, I'm going to get $10.80. And then since this is a sale, I know that it's going to make it cheaper. So I'm going to subtract the $10.80. This is really how much the sale is. So how much it's decreasing the amount by. So I'm going to subtract that from it, and I would end up with $25.19. Now, if it were like a tip or it were like tax, something like that, that would mean that instead of subtracting, I would add it. And always ask yourself, especially for ones like this, does it make sense, like with real life stuff? If a sweatshirt was $35.99 and it was on sale for 30% off, does this $25.19 seem like a reasonable amount? It should. So that does seem right. It makes sense for the numbers I'm dealing with in the situation. Final one. Pete had 140 candies. He kept 28 candies for himself and gave the rest away. What percentage of his candies did he give away? So this one, I'm looking for a percentage that's missing, and I have two numbers that are going to be part of it. So really what I'm trying to figure out here is the percent of a number. That's the kind of a problem that I'm dealing with. I'm trying to figure out the percent of candies he gave away. And there's a couple ways you can do this one. So I could set it up like this, and I know that I'm missing the percent, and I know the whole amount here. The whole amount is 140. So the 28 is how many he kept for himself. So one way you can do it is putting the 28 in there and solving it. So I probably cross multiply again on this one. Cross multiply 28 times 100 divided by 140, and I would get 20%. But this 20% is the amount that he kept, because 28 is how many candies he kept. We're looking for how many he gave away. So if he kept 20%, that means he gave away 80%. The other way that you could have done it, and this would have given you the same answer, if I wanted to, and I don't see what my eraser can just do, what you could have done is went and you could have subtracted to figure out how many candies he actually gave away. So I could have taken 140 minus 28, and then I could have put 112 in here instead and then solved it the same way. And that would have still given me 80%. And if we think, does this answer make sense? 80%? Well, if he's only keeping 28 out of 140, that's way less than half. So it's about 1/5, or it's exactly 1/5 of how many candies he had. So that number does make sense. So when you're solving these percent problems, kind of use this process. Say, what kind of a problem is it? Is it simple interest? Is it finding percent change? Is it using percent change? Or is it percent of a number? And then just go through and think, okay, what am I trying to figure out? Solve it. And then always ask yourself, does my answer make sense at the end? And that will help you kind of check to see if you're doing it right. So as always, make sure you ask any questions. If you're confused, try a few problems, rewatch the video if you think you need a little bit more help, and just make sure you reach out if you need help.